All right, let's take a look at the practice test. For the instructions, we're asked to find the period, phase shift, and vertical shift. Then we want to sketch the graph. All right, before we jump in and look at any problems, I want to give you a quick review of how to graph the secant function. So something like y equals the secant of x. Again, we have this guy graphed in red already. So in the case of the secant function, the reciprocal function is the cosine function. So we're using that as a guide. So y equals the cosine of x. That guy is graphed as a dashed curve because that's what we do with a guide, and it's in green. So when we look at the two graphs together, we can notice a few things. The first thing is that anywhere where the y value is 1, so something like right here at negative 2 pi, right here at 0, right here at 2 pi, there's a shared point. So between the cosine function and the secant function, and that's because, again, if you think about the definition, we have the secant of x is equal to 1 over the cosine of x. Well, if I had a cosine value of 1, 1 over 1 is 1, so the secant value would be 1 as well. And then the same thing is true anywhere where the y value is negative 1, because 1 over negative 1 would also be negative 1. So you have this at negative 3 pi, again, a y value of negative 1, and then negative pi, and then 3 pi, so on and so forth. So those are where you're going to have these shared points. Additionally, you'll notice that anywhere where you have what we call a hill, so this right here would be described as a hill or a maximum on the cosine graph, that's going to give you a local minimum on the secant graph, or you could call that a valley. So a lot of times you'll hear the hills and valleys are interchanged. So that's how I know which direction this guy is going to face for the secant function. This guy is a hill, so this is a valley. This guy is going to be a valley, so this guy is a hill. This guy is a hill, so this is a valley, so on and so forth. Now, the only other thing you really need to know is where to find the vertical asymptotes for your secant function. And this is going to happen here because we don't have any vertical shifts involved, anywhere where the cosine value is 0. So anywhere where you have an x-intercept. So something like pi over 2, we know that one. The cosine of pi over 2 is 0. So you'll notice that on the cosine graph, this is an x-intercept. And let me do that a little bit further down so you can still see that. And then also at 3 pi over 2, the cosine of 3 pi over 2, that's 0. So again, that would be an x-intercept. Why does that give me a vertical asymptote for the secant function? Well, again, it's 1 over the cosine value. And if the cosine value is 0, 1 over 0 is undefined. So you get these vertical asymptotes here and here and here. So odd multiples of pi over 2. One thing I want to call your attention to is that if you look at this over one cycle, so we've graphed this a million times. So let's say we go from 0 to 2 pi. Think about where the x-intercepts occur, because when you get vertical shifts, so shifting up or down, this is no longer going to be done by finding the x-intercepts. You're going to think about what is a quarter of the way through and what is 3/4 of the way through. So if you start here, again, a quarter of the way through, you're going to hit that pi over 2 or the x-intercept. You're going to come down and you're going to come back up. And then 3/4 of the way through, you're going to hit that x-intercept, and then you're going to finish up your cycle. For myself, I always just graph one cycle when I do this. Your teacher may give you a specific interval over which they want you to graph this guy. Just follow that. If you're self-studying, I think just doing one cycle on your own is fine. And then you can just check Desmos. I gave you links for everything and just see what the rest of it looks like. So for something like this, again, you have a shared point here. And I know that this is a hill, so this would be a valley. And I'm just going to draw this part right here. So again, this gets drawn to where it approaches the vertical asymptote, but doesn't touch it. And let's just say this point is about right there. It's not going to be perfect. And let's just say again that this is a valley, so this is going to be a hill. So this right here would approach that vertical asymptote, but not touch it. And the same thing for this. So it's going to approach that vertical asymptote and not touch it. And again, this would be a shared point here. Let's just say it's about right there. Not going to be perfect. And this is a hill, so this would be a valley. So this will approach the vertical asymptote and not touch it. Again, this would be one cycle of the secant graph. This is good enough for me if I'm self-studying, but if you want to do more, of course, you can. All right, for problem 1, we have f of x equals 1/2 secant of x plus pi over 2, and then minus 1. So what I'm going to do is just start off with the basic information that we're asked for. We want to find the period, we want to find the phase shift, and we want to find the vertical shift. So those are pretty easy to do. Now, normally I would factor, but in this case, you'll see that the coefficient of x is 1, so there's no need to factor here. So for the period, it's just going to be the standard period for secant, which is 2 pi. So what you would do here, if you have something that's not 1 for the coefficient, you just take that standard period of 2 pi, and you divide by whatever that is. Then for the phase shift, you're going to go inside the parentheses, and you're going to say, how can I undo what's being done to x? Well, you have this plus pi over 2 here, so that means you're going to the left pi over 2, because I need to subtract away pi over 2 to undo what's being done to x. Then for the vertical shift, you have this minus 1 that's outside here. So I'm just going to say that we're going to go down by 1. Now, once you've done that, what you would want to do is copy this right here, but you want to replace your secant with cosine. So you would say that you have f of x is equal to 1/2, and then cosine of, you're going to have this x plus pi over 2, and then minus 1. We're going to come down here to a little fresh sheet of paper. And again, when you try to graph something like this, there's different approaches you can use. So what a lot of people will do is they'll do the quarter period method. And all that is you start off with the first x value coming from the phase shift. So in other words, we know that this guy right here, we shifted pi over 2 units to the left. So I'll start off with this being negative pi over 2. And then from there, to get the additional x values, you would just add quarter periods. So the period is 2 pi, so a quarter period, let me write this right here. Let me put a little border and put the quarter period is going to be 2 pi over 4, which is pi over 2. You just take this and you keep adding pi over 2. So negative pi over 2, let me write this out. So negative pi over 2 plus pi over 2. So that's going to give me 0. So this right here would be 0. And then you can do 0 plus pi over 2. So this is pi over 2. And then pi over 2 plus pi over 2. So pi over 2 plus pi over 2. That would be 2 pi over 2, which of course is pi. So let me write this as pi. And then to get a common denominator, you could write this as 2 pi over 2, and then plus your pi over 2, and that's 3 pi over 2. So that's basically all you have to do. We have the x coordinates that we're going to work with for this guy right here. Now, let me drag this over a little bit. If you wanted to do this using an alternative approach, let me put a comma in each case, you can of course use graphing transformations for x. So let me put a little border here, and let me put for x, the only thing you have to do is subtract away. So we're going to subtract this pi over 2. Now for this one, let me actually move this right here, and I'm going to put a little border. This is just an alternative approach. I don't want anybody to get lost, so forget about this for right now. To do it this way, you have to start off with your basic points for the cosine function. So y equals the cosine of x. And so you have your 0, 1, you have your pi over 2, 0, and then you have your pi, negative 1, you have your 3 pi over 2, 0, and then you have your 2 pi, 1. Well, what you're doing is you're taking each x value here, and you're just going to subtract away pi over 2. And you're going to see that it's going to match what we found using the quarter period method. Just some people don't like doing this, and in a lot of cases, it's actually a lot more work. So I'm just going to do this real quick and just show you get the same thing. This is just going to be for the x values, and then I'm going to erase it, and we're going to work on this and get the y values. So when you subtract away pi over 2 from 0, you get negative pi over 2. So that matches. So now I'm working with the x value in each case. So I want to do pi over 2 minus pi over 2. And of course, that's going to give me 0, just like I got there. So the same thing. Then here I have pi minus pi over 2. So again, you could write that as 2 pi over 2. And so 2 pi over 2 minus pi over 2, that would be pi over 2. Again, that matches what we got there. 3 pi over 2 minus pi over 2. Let me write this out. So 3 pi over 2 minus pi over 2. That's going to give me 2 pi over 2, which is just pi. And then the last one, we have 2 pi. So 2 pi, we could write that as 4 pi over 2, and then minus pi over 2, and that's going to be 3 pi over 2. So this right here would be 3 pi over 2. So you can see everything is going to match. The main thing is to understand that if you look at horizontally what's happening, we are just going to have a shift to the left by pi over 2 because of this subtract away pi over 2 to undo what's being done to x. So that's basically it. And actually, we can just keep this and erase this and move this over here, because what you do want are those y values here from the original y equals cosine of x to get your y values for this guy right here. Let me write out y, and let's think about what we're doing. We have this 1/2 that's multiplying this guy, so we're going to multiply by 1/2. So we're going to do that first. The second thing is we're going to subtract. So we're going to subtract away 1. Now, when you think about what's happening here, well, you can say that you have a vertical shrink by a factor of 1/2. Or again, some people will say a vertical compression by a factor of 2. It's just different ways to phrase the same thing. You could just think about the fact that each y coordinate is being either multiplied by 1/2 or divided by 2. That's what you want to realize. Then when you subtract away 1, you're shifting down by 1 unit. So what you could do is just take this 1 right here and multiply by 1/2 and then subtract away 1. If you didn't like that, if you don't like going through these steps here, you could always plug in. So you could take this negative pi over 2 right here and plug it in for x there. But notice what's going to happen. You're going to end up with this part right here, so this part right here, being the same as this right here. In other words, negative pi over 2, if I plug that in there, negative pi over 2 plus pi over 2 is 0. The cosine of 0 is 1. So this part right here exactly matches this right here. So that's why you can just shortcut that and say, okay, well, I would have 1 times this 1/2 and then minus 1. That's all you have to do. If you did this, you would have 1 times 1/2. That's going to be 1/2, and then 1/2 minus 1. So 1/2 minus, let's go 2 over 2. Well, that's going to be negative 1/2. So that's going to be the y coordinate there. And that's all it is. So this is negative 1/2. Continuing, if you came down here again, if you plugged in a 0, so 0 goes in right there. 0 plus pi over 2 is pi over 2. The cosine of pi over 2 is 0. So notice that this right here would match this 0 right here. Again, the cosine of pi over 2 is 0. That matches that. So you could shortcut this and just say, since I know the result of this would be 0, I just want to go 1/2 times whatever this is. That's what I'm going to get. So times 0 and then minus 1. 1/2 times 0 is 0. 0 minus 1 is negative 1. So that's that right there. Close that down. Then let me just do one more of these. If I plugged in a pi over 2 here, pi over 2 plus pi over 2, that's going to be 2 pi over 2. And 2 pi over 2 is pi. So this right here is going to be the cosine of pi, which is negative 1. Again, it perfectly matches that right there. It's going to every time. So you're going to have 1/2 and then times this negative 1 and then minus 1. So 1/2 times negative 1, that's going to be negative 1/2. So let me write negative 1/2. And then minus 1 you could write as 2 over 2. So this would be negative 3/2. Let me erase this and say this is negative 3/2. Close that down. And then these two can come from these two. So this is 0 here, this was 0 here. So this will end up being negative 1. And this is 1 here, this was 1 here. This will be negative 1/2. And that's all you really need to consider when you're getting these points. Again, you can use the quarter period method for x, or you can use graphing transformations. Most students will just rely on the quarter period method. The graphing transformations can get a little bit challenging to both figure out and then also to do, because sometimes it's a little bit more tedious than the quarter period method. In terms of y values, again, I would just use graphing transformations. It's very, very straightforward. So once you have all of these points, you're ready to basically sketch your graph. Let me go ahead and grab this real quick. If you look at what we have here, you have negative pi over 2 comma negative 1/2. So that's that point right there. Negative pi over 2 comma negative 1/2. Then you have 0 comma negative 1. So that right there. You have pi over 2 comma negative 3/2. You have pi comma negative 1. And you have 3 pi over 2 comma negative 1/2. Again, I have a link for you on Desmos if you want to click that. You could see things in more detail if you're having trouble with anything on the screen here. We know that at the start of the cycle, they're going to share a point. So we have that right there. That's also going to happen midway and then also at the end of the cycle. So that's a shared point, a shared point, and a shared point. Now, in terms of this guy right here and this guy right here, I want you to remember that on your basic cosine graph, you have an x-intercept a quarter of the way through and 3/4 of the way through your cycle. So what's going to happen is if you look at a quarter of the way through and 3/4 of the way through here, you're not getting an x-intercept because this has been shifted down by 1 unit, but you're still going to get the vertical asymptotes. And the reason for that is when you plug in for x, let's say you plug in a 0, this right here is a quarter of the way through. So once you go through this, you're going to end up with pi over 2. For this one, when you plug that in, once you go through this, you're going to get the 3 pi over 2. So you're going to get undefined in each case. Let me show you that. So f of, let's say you plug in a 0, you get 1/2 and then secant of. Of course, this would be 0 plus pi over 2 and then minus 1. So 0 plus pi over 2 is pi over 2. So the secant of pi over 2, we know that's undefined. And then if you did the other one, so let me erase this and this. And let's say we did pi. So plug in a pi there and a pi there. Well, now pi plus pi over 2, that's 2 pi over 2 plus pi over 2. That's 3 pi over 2. So you'd end up with a secant of 3 pi over 2. Again, that's undefined. So all you have to do is remember that at a quarter of the way through and 3/4 of the way through, that's where you're going to have your vertical asymptotes. Another thing that a lot of teachers will do is they'll look at this vertical shift here. So this is -1 here. So I've been shifted down by 1 unit. So you could, if you wanted to, draw a new midline at y equals -1, because normally it's y equals 0, but it's been shifted down by 1 unit. So let's say something like that. So let's say this is y equals -1. Again, this is your new midline. So any point that lies on that midline, so 0 comma -1, pi comma -1, so on and so forth, so where the y value is -1, well, the x value for that point is going to be a vertical asymptote for your secant function. Now, once you have all this, you're ready to sketch your graph. If this is a hill or a maximum for the cosine function, this is going to be a valley or a local minimum for the secant function. So this guy right here is going to be drawn to where it approaches, again, you're going to have a vertical asymptote at x equals 0. It's not drawn, so you're just going to approach the y-axis there. And then this over here, this is a minimum for the cosine graph, so it's going to be a local maximum for the secant graph. So the valley is going to become a hill. So this right here is going to approach your y-axis. Again, that x equals 0 is a vertical asymptote, and then this right here would approach that vertical asymptote there, so that x equals pi. And then over here you have, again, a maximum for cosine, so that's going to be a local minimum for secant. So this is going to approach that x equals pi, so that vertical asymptote, but not touch it. Again, if you're self-studying, feel free to just do one cycle. If you're somebody who's getting an assignment, then just follow what your teacher tells you. They'll generally say that they want to sketch it over a certain interval. All right, for problem 2, you have f of x equals 1/2 secant of 2x minus 2 pi over 3, and then plus 2. I like to factor these. I think it makes it easier to find the phase shift, but again, that's personal preference. So let's go f of x is equal to 1/2, and then secant of, I'm going to pull out the 2. So inside you have x minus pi over 3. Close all this down, and then plus 2. All right, so looking at this, if you want the period, you're going to look at, again, the standard period, which is 2 pi, and you're going to divide by the coefficient of x in unfactored form, or the number outside of the parentheses if it's factored. So you'd be dividing by 2. So 2 pi over 2 is going to be pi. You could write out the quarter period. We're going to need that. So that would be pi over 4. That's all it is. Then you have your phase shift and you have your vertical shift. And thinking about the phase shift, again, when you factor it, it's really easy. You're going to come inside the parentheses here. You're going to say, how can I undo what's being done to x? Well, I have minus pi over 3. So to undo that, you need to add pi over 3. So that means I'm going to the right pi over 3. And then for the vertical shift, I have this plus 2 here. So that means I'm going up 2. So at this point, what I'm going to do is just replace secant with cosine and just graph that guy. So f of x equals 1/2, and then cosine of, you have 2 times the quantity x minus pi over 3. And then you have this plus 2 here. And let me paste this in here. You can use the quarter period method to find the x values for this guy right here, or you can use graphing transformations. In this particular instance, the graphing transformations for x are going to take longer, so the quarter period method would be faster. I'm just going to show you the procedure for each, just so you have it, and then on all the future problems, I'll just use the quarter period method, because in most cases, it's a little bit faster. So let me just start off by writing y equals the cosine of x, just for reference. So we have our points. So we know that we have 0, 1 to get things started. Then we have pi over 2, 0. Then we have pi, negative 1. Then we have our 3 pi over 2, 0. And then lastly, we have 2 pi, 1. Now, if we think about the quarter period method, we really don't need to worry about any of these x values. We're just going to start with a phase shift. So we know that we're undoing what's being done to x. Again, we're shifting to the right by pi over 3 because we have minus pi over 3. So we need to add pi over 3 to undo that. So you just start with that. So the phase shift would say that I'm going to have pi over 3 there. And then at that point, you're just going to add quarter periods. Don't worry about these x values. You're just adding quarter periods. So the quarter period, as we talked about earlier, is pi over 4. To make your life easier, just multiply this by 3 over 3. So you have a common denominator. So that would be 3 pi over 12. So this one right here, you'd multiply by 4 over 4 temporarily. That would be 4 pi over 12. So 4 pi over 12 plus 3 pi over 12, that is 7 pi over 12. Then 7 pi over 12 plus 3 pi over 12, that is 10 pi over 12. You can simplify that, but don't do it yet. 10 pi over 12 plus 3 pi over 12, that is 13 pi over 12. 13 pi over 12 plus 3 pi over 12, that is 16 pi over 12. Now, get rid of this. You don't need it. And you actually don't need this anymore either. At this point, let me go through and show you how you could have gotten these using graphing transformations with x. And actually, let me simplify this real quick. So if I divide 10 by 2, I'm going to get 5. And 12 divided by 2 is 6. Here, 16 divided by 4 is 4. And 12 divided by 4 is 3. Thinking about what we would do for x if you wanted to go that route, you have to undo things in a reverse order. I always use the saying that if you're typing out a Word document and you hit Control Z, so you undo something, you're going to undo the last thing that you did. You don't undo the first thing that you did. So if you look at what we have here, again, you would go inside of parentheses first because of the order of operations, you would multiply second. So if I'm undoing that, now this is first and this is second. So how do I undo multiplication by 2? I want to multiply by 1/2. How do I undo subtracting away pi over 3? I want to add pi over 3. So if you think about where this is coming from, I could box this off for a second, and you could just plug in. Let's say I pick something like 7 pi over 12, and I just do this part. So we have 2 times the quantity. Let's go 7 pi over 12, and then minus pi over 3. Let me grab this real quick and go to another page because this is not going to fit. So let me paste this in here just so you can see what's being done. So here you could write this as 2 times 7 pi over 12 minus, multiply this by 4 over 4. This is 4 pi over 12. And so this becomes 2 times, you would have, when you subtract this away, 3 pi over 12. And 3 pi over 12 is pi over 4. So this becomes 2 times pi over 4. So notice that the first thing I did was subtract away pi over 3. Now, the next thing I'm going to do is multiply by 2. So this becomes 2 times pi over 4, which is pi over 2. So notice that I plugged in 7 pi over 12, and I got pi over 2. Let me go back up. So 7 pi over 12, there's pi over 2. But the problem is, I don't know the 7 pi over 12. I'm working with the basic points for cosine. I know pi over 2, and I'm trying to get 7 pi over 12, so I have to go in reverse. In other words, I have to undo what was being done so that I can go from this pi over 2 to the 7 pi over 12. So to do that, you have the multiply by 1/2 and then add pi over 3. Let me come back down. Let me see if I can make that make sense for you. So if you wanted to undo this, in other words, go backwards, you would undo the last thing that was done. So the last thing that was done is we multiplied by 2. Let me put a little border. So to undo that, I need to take this pi over 2 and I need to divide by 2 or multiply by 1/2. So you have pi over 2 and I'm going to multiply by 1/2 and that's going to give me pi over 4. So notice at this point, that puts me back to this pi over 4. So 2 times pi over 4 gave me pi over 2. To undo that, I multiply by 1/2 or divide by 2. That puts me back to this point right here. So going back through, again, to this right here, I need to undo the subtraction now of pi over 3 because that's what's happening right here. I'm taking the 7 pi over 12 and subtracting away pi over 3, which we wrote as 4 pi over 12. So in the second step, you're going to say that you have this pi over 4, and I'm going to add this pi over 3 that was subtracted away. And so this becomes 3 pi over 12 plus 4 pi over 12, just getting a common denominator. And that gets me back to the 7 pi over 12. So that's this right here that I was plugging in for x when I started. So when you undo things, you have to go in the reverse order. So just keep that in mind. So coming back up, again, you see that 7 pi over 12. So I know the first time you see that, it might not make a whole lot of sense, but what I would suggest is just stop the video here and go through with each one of these guys and plug in and write down the steps, then go in the reverse order. So you're going to see how these guys are related. You'll be able to say, okay, if I'm starting with pi and I multiply by 1/2 and then add pi over 3, I'm going to get the 5 pi over 6. If I start with 3 pi over 2 and I multiply by 1/2 and then add pi over 3, I'm going to get the 13 pi over 12, so on and so forth. So now that that's out of the way, let's just do the y. And I know a lot of you find the y values, getting those a lot easier because it's very straightforward. So in this particular case, again, all I'm doing is I'm multiplying by 1/2. So I'm going to multiply by 1/2, and then I'm going to add 2. So very, very straightforward. This right here is going to give me a vertical compression by a factor of 2, or again, you could say a vertical shrink by a factor of 1/2, whatever you want to say there. You're just taking the y coordinate and dividing by 2 or multiplying by 1/2. Then when we add 2, we're just shifting up by 2 units. Again, if you were to plug in pi over 3 minus pi over 3 is 0, 2 times 0 is 0, the cosine of 0 is 1. So it just matches this. So all you have to do is just take that y coordinate, that's what you're going to get anyway, and just say, okay, it's 1/2 times whatever that is, in this case it's 1, and then plus 2. So just following the order of operations, multiply by 1/2, and then add 2. So this would be 1/2 plus 2, so you could say that it's 1/2 plus 4 over 2, so that is 5/2. Let me erase this and put this in as 5/2. This right here, 0 times anything is 0. So you can just say that you're just going to add 2. So this is 2 right here. And then -1 times 1/2 is -1/2. And then let's add 4 over 2. So this would be 3/2. And then for the rest of them, you can just copy. So for 0, we know that's going to be 2. And then for 1, we know that's going to be 5/2. That's basically it. So let's go ahead and grab this. So going through these points, again, they're tough to see because of the scale of things. You just click the link on Desmos to follow more closely. You have this pi over 3, 5/2. You have this 7 pi over 12, 2. you have this 5 pi over 6 comma 3 halves, you have the 13 pi over 12 comma 2, and then the 4 pi over 3 comma 5 halves. So I'm just going to erase this real quick. We know that the start of the cycle, you're going to have a shared point. We know that that also occurs at the middle and then at the end. So those are shared points on both graphs. When you look at a quarter of the way through and 3/4 of the way through, again, that's where you can have your vertical asymptotes for the secant function. So here that's going to happen at x equals 7 pi over 12 and x equals 13 pi over 12. If you're not comfortable with that or you can't remember it, remember you can always use this +2 here, this vertical shift, to give yourself a new midline. So what you could do is draw this in right here and say this is y is equal to 2. So any point that intersects that line y equals 2, so the y value is 2, well, that's where you're going to have a secant value that's undefined, and so you're going to get vertical asymptotes there. In other words, if I plugged in a 7 pi over 12, you can do that real quick if you want. So the secant of, you have this 2 times 7 pi over 12, and then minus 2 pi over 3, close that down, you're going to see that this right here, once you evaluate, once you go through this, you're going to have pi over 2. So let's just do that real quick so this is crystal clear. This cancels with this and gives you a 6. And this you could multiply by 2 over 2. So what would that give you? It would give you the secant of, you would have 7 pi over 6 minus, this would be 4 pi over 6. So this would be the secant of, you would have 7 pi minus 4 pi, that's 3 pi. So what is 3 pi over 6? That's pi over 2. So this part right here is going to be undefined, so you're going to get a vertical asymptote. I'll let you do the other one on your own. Again, if you plug in a 13 pi over 12 and you go through the steps, you're going to end up with 3 pi over 2. So the secant of 3 pi over 2 is going to be undefined. So let me get rid of that, just so we know what's going on. So I'm going to draw this to where it approaches that vertical asymptote. And it's not supposed to touch it, but I might go over a little bit. And this right here, again, it's going to approach the vertical asymptote and not touch it. I'll get as close as I can. This would approach the vertical asymptote and not touch it. And I went over a little bit there. And then this one would approach the vertical asymptote and not touch it. All right, let's take a look at problem 3. So we have f of x equals 3 secant of x over 3 plus 7 pi over 4 plus 1. I would, again, factor this. It just makes it easier. So let's say that we're going to pull out a 1/3 here. So this is out in front of some parentheses. So you have your x plus. What goes here? Well, how do I undo multiplication by a third? Well, I need to multiply by 3. So 7 pi over 4 times 3 would be 21 pi over 4. And so now it's very easy to get the phase shift. Let me start off with a period. So the period here is going to be 2 pi, the standard period for secant, divided by 1/3. So that's 2 pi times 3, which is 6 pi. Then you have your phase shift. And then all I'm going to do for that is come inside the parentheses here and say, how do I undo this? Adding 21 pi over 4, we need to subtract away 21 pi over 4. So that means I'm going to the left, 21 pi over 4. And then for the vertical shift, you have this plus 1 here, so I'm just going up 1. So all you have to do, let me just copy this and come down to a fresh sheet. You're just going to erase this and just write in cosine, and you're going to graph that. Now, again, you could use graphing transformations, but again, in terms of x, it's a little bit slower in this case, and I know a lot of you get confused by it, so you might want to work on that a little bit on your own if you need to. I'm just going to use the quarter period method just to speed this up a little bit. So what I'm going to do is write out y equals the cosine of x, and we'll say that we have a point which is 0, 1. We have a point which is pi over 2, 0. We have a point which is pi, -1. We have the 3 pi over 2, 0, and then we have 2 pi, 1. So we know these points already, and all we're going to do is think about, first, what is the phase shift? So the phase shift is minus 21 pi over 4. So that's going to be your first x-coordinate, so negative 21 pi over 4. And then to get the next ones, you're just going to go through and add quarter periods. That's all you need to do. Nothing complicated. We know the period was 6 pi, so the quarter period here is going to be 6 pi over 4. Now, you could simplify that and say it's 3 pi over 2, but notice that you want to keep it this way so you have a common denominator. Negative 21 pi over 4 plus 6 pi over 4, that would be negative 15 pi over 4. And then negative 15 pi over 4 plus 6 pi over 4, that is negative 9 pi over 4. Then negative 9 pi over 4 plus 6 pi over 4, that is negative 3 pi over 4. Then negative 3 pi over 4 plus 6 pi over 4, that is 3 pi over 4. So now we have the x values. We want to get the y values. Again, you can use the plug-in method, but just realize that if you plug in something like negative 21 pi over 4 for x right there, well, this right here is going to end up being this right here. Negative 21 pi over 4 plus 21 pi over 4, that's 0. 1/3 times 0 is still 0. Cosine of 0 is 1. So the shortcut here is just to say that I'm going to multiply by 3, so 3 times whatever this y coordinate is, and then add 1. That's all it is. So 3 times 1 is 3, plus 1 is 4. So this would be 4. Then for this one, 0 times 3 is 0, then plus 1 is 1. And then for this one, negative 1 times 3, and then plus 1. So negative 1 times 3 is negative 3. Negative 3 plus 1 is negative 2. So this is negative 2. And then for this one, we're going to copy, so this is 1. And then for this one, we're going to copy, so this is 4. Okay, let me grab this, and let me paste this in here. So you have this negative 21 pi over 4, comma 4. So that's going to be something that's shared. Then you have negative 15 pi over 4, comma 1. That's going to be this point right here. Again, the x value there would be a vertical asymptote because this is a quarter of the way through. Then you have this negative 9 pi over 4, comma negative 2. So again, that's a shared point. Then you have this negative 3 pi over 4, comma 1. So again, that's where you're going to have a vertical asymptote. So at that x value there at negative 3 pi over 4 for the secant function, you're 3/4 of the way through. And then here you have 3 pi over 4, comma 4. So again, that's going to be a shared point. Let me get rid of this. And again, once you know where the vertical asymptotes are and you sketch that guy, so again at negative 15 pi over 4 and negative 3 pi over 4, where then you're just considering, okay, well, this is going to be a hill, so here this is a valley. This is going to be a valley, so this is a hill. This is going to be a hill, so this is a valley. So I know that I can draw this guy right here, again, to where it approaches the vertical asymptote, but doesn't touch it. And this piece right here is going to approach the vertical asymptote and not touch it. And then the same thing here, approach but not touch. And then this one right here, we're going to approach the vertical asymptote but not touch it. All right, let's take a look at problem 4. So here we have f of x equals 3 secant of x over 2 plus pi over 3 and then minus 2. So again, I'm just going to factor this just to make finding the phase shift easier. So f of x equals, we have our 3, and then we have secant of. Let me pull out a 1/2 here. And then inside you'd have your x plus, how do I undo multiplication by a half? You need to multiply by 2. So you'd have 2 times pi over 3, which is 2 pi over 3. And then we'd have minus 2 here. So just sliding down, we just want the basic information. So what is the period here? And that's going to be the standard period, which is 2 pi divided by 1/2. So that's going to be 4 pi. What is the phase shift? Looking at the inside here, how do I undo what's being done to x? Well, I have plus 2 pi over 3. So to undo that, I need to subtract away 2 pi over 3. So this is left 2 pi over 3. And then for the vertical shift, we have this minus 2 here. So that means I'm going down 2. That's all it is. So all I'm going to do here is just, again, copy this. Let me go f of x is equal to 3. Instead of secant, let's write cosine, and then we'll copy the rest. So you have this 1/2 times the quantity x plus 2 pi over 3, and then you have the minus 2. Okay, let's grab this, come down here and paste this in. Let me write out, once again, y equals the cosine of x. You have your 0, 1. You have the pi over 2, 0. You have, let me make this better here. So pi over 2. And then you have pi, negative 1. Let me make that better. And then you have 3 pi over 2, 0. And then lastly, you have your 2 pi, 1. Okay, so for the first thing, we're going to just use the phase shift. Again, you have minus 2 pi over 3 here to undo what's being done to x. So this is minus 2 pi over 3. I'm going to the left by 2 pi over 3. To get the next x value, you're going to add a quarter period. The period was 4 pi, so a quarter period is pi. So a quarter period is going to be pi. You might as well say it's 3 pi over 3. So negative 2 pi over 3 plus 3 pi over 3, that would give me pi over 3. Let me make this better here. And then you're just going to keep adding quarter periods. So pi over 3 plus 3 pi over 3, that is 4 pi over 3. And then 4 pi over 3 plus 3 pi over 3, that is 7 pi over 3. And make these better here. And then this one right here, 7 pi over 3 plus 3 pi over 3, that is 10 pi over 3. Okay, so we have the x values that we need now, and we just want to get the y values. Again, all you have to do is think about the fact that if you plug this in here, so negative 2 pi over 3 plus 2 pi over 3, that's 0. 1 half times 0 is 0. Cosine of 0 is 1. So it just matches that. So all you have to do is take this and say I'm going to multiply by 3 first and then subtract away 2. So in other words, you'd have 3 times 1 and then minus 2. Then here, you'd have 3 times the y value is 0, then minus 2. Then here, you'd have 3 times the y value is negative 1, then minus 2. So this is 3 times 1, that's 3, then minus 2, that's 1. So this is 1. 3 times 0 is 0, minus 2 is negative 2, so negative 2. 3 times negative 1 is negative 3, then negative 3 minus 2 is negative 5. So this is negative 5. Let's close all this down. Again, for these you can copy. So for 0, it's going to be negative 2. And then for 1, it's going to be 1. So grab this and just go through this with me real quick. You have negative 2 pi over 3 comma 1. Again, that's a shared point. Then you have a quarter of the way through pi over 3 comma negative 2. So the x value here, that's going to be a vertical asymptote for your secant function when you draw it. Again, if you plugged in a pi over 3, you went through the stuff there, you're going to end up with a secant of pi over 2, and the secant of pi over 2 is undefined. So you'd have a vertical asymptote right here at pi over 3. Then you have 4 pi over 3 comma negative 5, so it's going to be this right here. That's going to be a shared point. Then this guy right here, again, that's 3/4 of the way through. You can have another vertical asymptote there. If you took that x value, that 7 pi over 3, and you plugged it in, you'd end up with the secant of 3 pi over 2, and so that's undefined. So that's your vertical asymptote there at x equals 7 pi over 3. Then this point right here to finish up the cycle is 10 pi over 3 comma 1. Again, that's a shared point. So let me get rid of this, and we can just sketch this guy real quick. So we know that, again, this is a hill, so this is a valley. This is a valley, so this is a hill. And then this is a hill, so this is a valley. So I'm just going to sketch this to where it approaches the vertical asymptote, but doesn't touch it. Same thing here. Approach, but not touch it. So that right there. And then we'll do this one right here. So approach, but not touch it. All right, for problem 5, we have f of x equals 2, secant of x over 2, minus 3 pi over 4, then plus 1. Slide down a little bit. Let's write f of x is equal to 2 secant of, let me pull out the 1/2 there. So inside you have x minus, again, I'm just going to multiply this by 2. So 3 pi over 4, let me show this. 3 pi over 4 times 2. This would cancel with this and give me a 2 down there. So this is 3 pi over 2. And then we can just close this stuff down, and you have the plus 1 there. Okay, so looking at the period, this is the first thing we want to know. You're going to have 2 pi divided by 1/2, so that's 4 pi. Looking at the phase shift, we know that we have this minus 3 pi over 2. So I'm just going to add 3 pi over 2 to undo that. And so that's going to give me a shift to the right. So to the right, 3 pi over 2. Then the vertical shift here, you have this plus 1. So I'm just going up 1. Let me bring this over here and erase this and this. I'm going to erase the secant and just put in cosine. And again, I just write out the basic points so we have them. Y equals the cosine of x. We'll have the 0, 1. We'll have the pi over 2, 0. We'll have pi, negative 1. We have 3 pi over 2, 0. And then you have 2 pi, 1. So looking at, again, the phase shift, we know that we went to the right by 3 pi over 2. So we're just going to start off with that. We're going to say that this is going to be 3 pi over 2. And then from there, you're just going to add quarter periods. Now the period was 4 pi. So a quarter period is pi. So let me write out that the quarter period, again, you could write pi as 2 pi over 2. So you have a common denominator. And so you're just going to go through and say 3 pi over 2 plus 2 pi over 2. That's 5 pi over 2. Then 5 pi over 2 plus 2 pi over 2. That's 7 pi over 2. Then 7 pi over 2 plus 2 pi over 2. That's 9 pi over 2. And then 9 pi over 2 plus 2 pi over 2. That's 11 pi over 2. So we've got the x values, and now we want the y values. Again, if I plug in a 3 pi over 2 here, 3 pi over 2 minus 3 pi over 2 is 0. 1/2 times 0 is 0. Cosine of 0 is 1. So all I have to do, instead of going through that, is just say, okay, I have that y value there. I'm going to end up multiplying it by 2 and then adding 1. So I'm going to say that this is 2 times 1 plus 1. I'm going to say that this is 2 times 0 and then plus 1. I'm going to say this is 2 times negative 1 and then plus 1. So 2 times 1 is 2, plus 1 is 3. So this is going to be 3, and then this down here would be 3 as well. You can just do that now. 2 times 0 is 0, plus 1 is 1. So let's say this is 1, and then this right here would be 1 as well. 2 times -1 is -2, and -2 plus 1 is -1. So this is what we want here. So again, looking at the start of the cycle, you have the 3 pi over 2 comma 3. That's a shared point. Quarter of the way through, you have 5 pi over 2 comma 1. Again, this right here, this x value, you're going to get a vertical asymptote there for the secant function. If you plugged in 5 pi over 2 for x, you're going to end up with the secant of pi over 2. So that's what this is going to turn into, and the secant of pi over 2 is undefined. So you get a vertical asymptote there at x equals 5 pi over 2. Then you get 7 pi over 2 comma -1. That's a shared point. Then you get to the 3/4 of the way through. Again, the x value there, that 9 pi over 2, well, that's going to give me, if I plugged it in for x there, you'd have the secant of 3 pi over 2. That's undefined. So you get a vertical asymptote there. And then if you get to the end of the cycle here, we're going to have 11 pi over 2 comma 3. So again, this is a hill, becomes a valley. This is a valley, becomes a hill. This is a hill, becomes a valley. So this would be drawn to approach that vertical asymptote. And then the same thing for this. This is going to approach that vertical asymptote. And I'll do that this way as well. And then this guy right there. All right, let's take a look at the cosecant function now. So again, here's where we have this red graph. That's your cosecant graph. And you're using the sine function as a guide here. So that's going to be this guy in green, this dashed curve. So think about what we know about the sine function. Let's just go from 0 to 2 pi. So here's 0 and here's 2 pi. You know you have an x-intercept at the start, at the middle, so that's going to be at pi, and at the end, that's 2 pi. So 0, pi, 2 pi. Beginning, middle, and end. So remember that. You have x-intercepts there. If you have an x-intercept, remember something like the sine of 0 is 0. The sine of pi is 0. The sine of 2 pi is 0. Well, if the sine value is 0, then the cosecant value is undefined. Because again, the cosecant of x is equal to 1 over the sine of x. So you'd have 1 over 0, which is undefined. So at 0, pi, 2 pi, 3 pi, so on and so forth, you're going to end up with these vertical asymptotes for the cosecant function. Now thinking about the other guys, so if you're at the quarter of the way and 3/4 of the way, that's going to be a shared point. So something like pi over 2 and then 3 pi over 2, those x values lead to a shared point. This is pi over 2 comma 1. This is 3 pi over 2 comma -1. So when you draw this, just keep that in mind when you have this guide function that you're making. So there's one cycle. At the beginning, you'd have a vertical asymptote. Again, because of the y-axis, I'm not showing it. You could put it there. It's not wrong, but you don't need it. Then you have your shared point at a quarter of the way through. At halfway, you're going to have a vertical asymptote. At 3/4 of the way, you have the shared point. And then at the end of the cycle, you have a vertical asymptote. Again, notice that when you look at this guy, your maximum point on the sine graph is going to give you a local minimum on the cosecant graph. And then notice that your minimum point on the sine graph is going to be a local maximum on the cosecant graph. So the hill becomes a valley, and then the valley becomes a hill. So for this one, again, you could just draw it like this. It's where it approaches your vertical asymptote. It doesn't touch it on each side there. And then you can do it like that and like that. And that's really all you need to do to graph one cycle. All right, let's take a look at problem 6. Here we have f of x equals 2, cosecant of x over 2 plus pi over 6 plus 1. All right, let me slide down a little bit. And again, I'm just going to factor this. So f of x is equal to 2 cosecant of, pull out the 1/2. Inside you have x plus, I'm going to multiply this by 2. Let me show this so nobody's lost. So pi over 6 times 2. This would cancel with this and give me a 3 down there. So this is pi over 3. And then once we close all this down, we'll put plus 1. So looking at our period, again, the standard period for cosecant is 2 pi. So you just want 2 pi divided by 1/2, which is 4 pi. Then for the phase shift, we're going to think about how do I undo what's being done to x inside the parentheses there. So we have plus pi over 3. To undo that, I want minus pi over 3. That means I'm going to go to the left pi over 3. And then for the vertical shift, we're going to think about this plus 1 right here. So we're going to go up 1. Let me copy this real quick. I'm going to try to write it as small as I can. So f of x is equal to 2. Instead of cosecant, let's write sine. And then I'll keep it in factored form. Again, if you want to use graphing transformations for x, if you don't, then it doesn't matter. So we're going to keep this factored. So x plus pi over 3 is on the inside. And then close this down and then plus 1. So just on this first one here, I'll show you the graphing transformations approach just so you get another one where you have some practice. But typically you would use a quarter period method. It's going to be faster. Let me just do that first. So y equals the sine of x. You have those basic points. So 0, 0. you're going to have pi over 2 comma 1. Then you're going to have pi comma 0. You have 3 pi over 2 comma negative 1. And then you have 2 pi comma 0. So here, the beginning, the middle, and the end, remember that you're going to have vertical asymptotes there on the cosecant graph because you have an x-intercept on the sine graph. And when we get to this one, because of the +1 here, it's not going to work out quite the same way. It's going to be where you have a y value of 1, and I'll show you that when you get to the graph. So first, quarter period method. Again, you would start with the phase shift, so it's minus pi over 3, so just minus pi over 3. That's all you have to do. And then you're just going to keep adding quarter periods. So we know the period here was 4 pi, so the quarter period would just be pi. And of course, to get a common denominator, you could really write this as 3 pi over 3. So negative pi over 3 plus 3 pi over 3. That's 2 pi over 3. And then you just keep doing that. That's all it is. So 2 pi over 3 plus 3 pi over 3, that's 5 pi over 3. And then 5 pi over 3 plus 3 pi over 3, that's 8 pi over 3. And then 8 pi over 3 plus 3 pi over 3, that's 11 pi over 3. Okay, so just in case you want to see it, if not, you can just skip ahead. If you wanted to do graphing transformations for x, again, you want to undo what's being done x. Again, if I plug this in and I go through the operations, I'm going to end up with 0. Negative pi over 3 plus pi over 3, that's 0. 1/2 times 0 is 0. If I plug this in, 2 pi over 3. 2 pi over 3 plus pi over 3. Again, we can do that real quick. That's pretty easy. So 2 pi over 3 plus pi over 3, that's 3 pi over 3, so that's pi. And then pi times 1/2 would be pi over 2. So all I want to do is reverse that because I don't know the 2 pi over 3. I know the pi over 2. So I've got to go in the reverse order. So what I did first here will be last. So this will be done second, and this will be done first. Got to go in the reverse order, and you have to undo stuff. How do I undo multiplying by 1/2? I need to multiply by 2. How do I undo adding pi over 3? I need to subtract pi over 3. So in other words, for this one, it's pretty simple. 0 times 2 would still be 0. Subtract away pi over 3, you have negative pi over 3. For this one, for pi over 2, you'd multiply by 2. Let me write this out. So pi over 2 times 2, that would just be pi. And then at that point, you'd have pi minus pi over 3. So you could say this is 3 pi over 3 minus pi over 3. That's 2 pi over 3. So again, that's another way to get these x values here. It does take a little bit longer. Now, your teacher might ask you for a description of the transformations, right? So in this case, you're multiplying by 2. That's giving me a horizontal stretch by a factor of 2. And you're subtracting pi over 3. So that means I'm shifting to the left by pi over 3. Okay, let me get rid of this. You can do the rest of them on your own if you want. I'll just stick with the quarter period method from here on out. And then in terms of getting the y values, again, it's very straightforward because if I plug this in, I know that the result of this is going to be this. So to shortcut the process, I can just say, well, it's 2 times whatever this is, so times 0, then plus 1. Again, to write this out, just for this one, so for y, the first thing is you're multiplying by 2. Then the second thing is you're going to add 1. So all you're doing is you're getting a vertical stretch by a factor of 2 and then a shift up by 1. That's all it is. So get rid of this. So for this one, it would be 1. So let's go 2 times 1 plus 1. This one is a duplicate, so we just need to do this one. So we're going to go 2 times negative 1 plus 1. So 2 times 0 is 0, plus 1 is 1. So this right here is 1. Then this one, 2 times 1 is 2, plus 1 is 3. So that is 3. Then this one, again, you could just copy from this one, so that's 1, and you could do that here, that's 1. 2 times negative 1 is negative 2, and then negative 2 plus 1 is negative 1. So this is negative 1. Now, what you want to focus on here is the fact that at the beginning, the middle, and the end, that's where you take those x values, and you're going to have vertical asymptotes when you draw the cosecant function. Let me grab this real quick, and let me bring this over here. So again, just looking at the points on the sine graph, you have negative pi over 3 comma 1, so that's this right here. You have 2 pi over 3 comma 3, that's this right here. Then you have your 5 pi over 3 comma 1, that's this right here. 8 pi over 3 comma negative 1, that's this right here. And then 11 pi over 3 comma 1, so that's that right there. Again, when you think about the beginning, the middle, and the end, so those guys right there, you take the x value, so in this case, it's negative pi over 3, you'd have a vertical asymptote. Here it's 5 pi over 3, you'd have a vertical asymptote. Here it's 11 pi over 3, you'd have a vertical asymptote. You could just plug this in and figure that out. So it's not in factored form here, but we can just do it real quick. So we have negative pi over 3. You'd have divided by 2. So let's just multiply by half. And then you have plus pi over 6. Well, obviously, this right here, this negative pi over 3 times a half, that would be negative pi over 6. Negative pi over 6 plus pi over 6 is 0. The cosecant of 0 is going to be undefined because the sine of 0 is 0. Again, the same thing would happen when you get right here. You plug in 5 pi over 3 and you do these operations, you're going to end up with the cosecant of pi in that case. And then when you get here at 11 pi over 3, again, you plug it in and do the operations, you're going to end up with the cosecant of 2 pi. So in each case, that would be undefined. So you get a vertical asymptote there. So we know where that's coming from here, here, and here. A lot of teachers do this instead. They say, okay, you have this plus 1 here. So the new midline would be y equals 1. So let me draw that in there. Not perfect, but good enough. So this is y equals 1. So another way to do this is, well, everywhere where I have a point where the y value is 1, so it hits that line, you're going to have a vertical asymptote. If you kept moving this way, you'd see you get that at negative 7 pi over 3. So in that guide function, the sine function, you would have negative 7 pi over 3, comma 1. You'd have negative 13 pi over 3, comma 1, so on and so forth. So you're getting vertical asymptotes at those x values. Let me get rid of this. You can draw it in on your graph if you want. And then basically, once you have this, remember that the hills and the valleys are interchanged. So I know this guy is going to go up and this guy is going to go down. So all I have to do is take that shared point and say, okay, I'm going to sketch this to where it approaches the vertical asymptote, and then the same thing over here. So approaches the vertical asymptote, and then this guy right here, this is going to face down. So we're going to approach the vertical asymptote and then approach the vertical asymptote. And that's basically it if you just want to do one cycle. If you want to keep going to the left or the right, that's up to you. But typically for self-study, I would just say do one cycle. All right, let's take a look at problem 7. So here we have f of x equals 3, cosecant of x over 2 plus 1. So this one right here is actually ideal for using graphing transformations for x, because if you notice, you just have that 1/2 that's multiplying x, so it's really easy to deal with that. So let me just write out, you don't need to really factor this. You can just put f of x is equal to 3. I'm going to just write the sine of, let me just write 1/2 x right now, and then plus 1. That way we have it. I'm just going to grab it real quick, come down here, and paste this in. We'll come back to this in a second. Let me come back up here. Let me just get the basic information going. So for the period, you're just going to take that 1/2, the coefficient of x there, and you're going to take 2 pi and divide it by that. 2 pi divided by 1/2 is going to be 4 pi. There is no phase shift. So the phase shift, you could just put none, right? Because you just have 1/2 that's multiplying x. You don't have some plus some number or minus some number. It's just 1/2 that's multiplying x. So really, you're just getting a horizontal stretch by a factor of 2, and I'll show you that in more detail in a moment. For the vertical shift, you do have one of those. Let me make this better here. So for that, you have this plus 1 right here. So you're just going to go up 1. Let me just write out y equals the sine of x. Hopefully you know these points at this time, but let me go 0, 0. Let me go pi over 2, 1. Let me go pi, 0 again. And then we have 3 pi over 2, negative 1. Let me move this up a little bit so it fits like that. And then we're going to finish up with 2 pi, 0. Again, x-intercept, x-intercept, x-intercept. That's what you want to remember. So if you just wanted to use graphing transformations here for x, all you really have is the 1/2 that's multiplying x. So to undo that, you just need to multiply by 2. That's why you're getting the horizontal stretch by a factor of 2. So all you'd have to do is come in here and multiply each x value by 2. That's all. So 0 times 2 is still 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. 2 pi times 2 is 4 pi. That's all you're doing. Now, if you wanted to use the quarter period method, you could. The phase shift is none, so you'd start with 0. And then at that point, you would just add quarter periods. Well, what is the period? The period is 4 pi. What's a quarter period? 4 pi over 4, which is pi. Notice that if I start at 0 and I add pi, I get to pi. Add pi, I'm at 2 pi. Add pi, I'm at 3 pi. Add pi, I'm at 4 pi. So either way you do it, it's going to be the same amount of time. In this particular case, I would say it would be faster to use the graphing transformations because you just multiply your x coordinate by 2 in each case to get the new x coordinate. That's basically all you have to do. All right, for the y values, again, you would multiply by 3 first, then add 1. So you would do 3 times 0 plus 1. Then you do 3 times 1 plus 1. Then this one is a repeat. You'd have 3 times negative 1 plus 1. So here, 0 times anything is 0, so it's just plus 1, which is 1. Here, 3 times 1 is 3, plus 1 is 4. And then this is a repeat. This would be 1, and this is 1. That's a repeat. And that comma should be moved down here. And then 3 times -1, that's going to be -3. And then -3 plus 1, that's -2. So this is -2. And now we have our points. So let me grab this. And let me just paste this in. Again, just going through these points, here is your 0, 1. Here's your pi, 4. Here's your 2 pi, 1. Here's the 3 pi, -2. And here's the 4 pi, 1. Again, when you think about the beginning, the middle, and the end, again, if I plugged in a 0, well, 0 over 2 is 0. Cosecant of 0 is undefined. If I plugged in a 2 pi divided by 2 is pi. So I'm right back to that pi, and we know the cosecant of pi is undefined. 4 pi, if I plug that in, 4 pi divided by 2, that's 2 pi. We know the cosecant of 2 pi is undefined. So at those x values at the beginning, the middle, and the end, I'm going to have vertical asymptotes. Again, if it's on the y-axis, don't worry about it. You don't have to put it in. You can if you want, but I wouldn't put it in. You have something to where you can approach, right? You just need that as a guide. Now, when we think about the other way to do it, again, you could have drawn a horizontal line, y equals 1. So anywhere where the y value is 1, that's where the x value is going to be undefined for the cosecant function. So you could do it like that to get the vertical asymptotes. Now the point right here, which is pi, 4, that's at the quarter of the way through. That's a shared point. And then the point right here, which is 3/4 of the way, that's 3 pi, -2. That's going to be a shared point as well. So to graph this, again, this is just going to approach the vertical asymptote. Again, I know it's not shown there, but x equals 0 would be a vertical asymptote. You're just going to approach the y-axis in that case. Same thing for this. You're going to approach that vertical asymptote. And then this guy right here is going to be drawn this way. And this right here is drawn this way. Again, I know that this goes up because this right here is a hill. So this would be a valley. I know that this goes down because this right here is a valley. So this would be a hill. So that's all you really need to know. All right, for problem 8, we have f of x equals 2, cosecant of 2x plus pi over 2, and then -2. So let me slide down here a little bit, and let me write f of x is equal to 2 cosecant of, let me pull out the 2, and then inside I would have x plus, how do I undo multiplication by 2? Well, I can multiply by half, so pi over 2 times a half would be pi over 4. Close that down, close this down, then -2. And then if we want to get the basic information, so what is the period here? The period is 2 pi divided by 2. So that's going to be pi. Then for the phase shift, I'm going to look at this inside. How do I undo what's being done to x? Well, I want to subtract away pi over 4 because here it's x plus pi over 4. So that means I want to go to the left, pi over 4. For the vertical shift, I want to go down by 2 because I have that -2. So down 2. Let me just copy this real quick. I'm going to try to make it smaller. So f of x is equal to 2. Instead of cosecant, let's write sine. And then we'll keep this in factor form. If you want to use graphing transformations, I'm not going to do it on this one. I'm just going to use the quarter period method because it's a little bit faster. So let me write y equals the sine of x. Let me go through our points again. So I think all of you have memorized them at this time. So we have 0, 0. We have our pi over 2, 1. Then we have pi, 0. Then we have 3 pi over 2, -1. This 3 could be a lot better there. And then lastly, we have 2 pi, 0. So you have your x-intercept at the beginning, the middle, and the end. That's very important to remember. So thinking about a way to do this, again, you could use graphing transformations if you want for x. You think about how to undo things. Well, you'd want to multiply by a half first to undo this one, and then you'd want to subtract away pi over 4 to undo this one. You go in the reverse order. This would be 1, this would be 2. But I'm not going to do that here because, again, that's very time consuming. To go quicker, if you want to use the quarter period method, what you would do is you would say, well, first I'm going to do my phase shift. So I'm just going to subtract away pi over 4. So this is minus pi over 4. And then at that point, you'd want to use the quarter period and just keep adding that. So what is the period? We know that's pi. So the quarter period is pi over 4. So negative pi over 4 plus pi over 4, that's going to be 0. 0 plus pi over 4, that's pi over 4. Pi over 4 plus pi over 4, that is pi over 2. But you could write that as 2 pi over 4 so that you can say 2 pi over 4 plus pi over 4. Well, that's going to be 3 pi over 4. Now, in terms of the y value, again, that's the easy one to get. If you plug in negative pi over 4 here, well, notice you put that in for x, negative pi over 4 plus pi over 4, that's 0. 0 times 2 is 0. So you would end up with the sine of 0. So remember, you're just plugging this in. You're going to end up with this right here at the end of the day right there. So the sine of 0 is 0. So the shortcut here is just to say that I have 2 times 0 minus 2. Multiplying by 2 first, then subtracting away 2 second. If you looked at this one, if you plugged in a 0 and you went through, 0 plus pi over 4 is pi over 4. Pi over 4 times 2 is pi over 2. So notice you're getting this. You want sine of whatever this is, and that's going to give you 1. So to shortcut this, I know this right here at the end is going to be this right here. So I'm just going to say that this is going to be 2 times 1 minus 2. You could skip this one because it's a duplicate. For negative 1, again, the process would be 2 times negative 1, then minus 2. So 2 times 0 is 0, and then 0 minus 2 is negative 2. So this is negative 2, and then you would copy that for this one, and then this one. And then 2 times 1 is 2, minus 2 is 0. So this is 0. And then for this one, 2 times negative 1 is negative 2, and negative 2 minus 2 is negative 4. Okay, so we have what we need now. Let me grab this real quick. And this one's really hard to see, so you might want to click that link on Desmos. I think it's going to be something you probably need to do because this is very, very small. It's hard for me to even see, and I'm looking straight at it. So this point right here is negative pi over 4 comma negative 2, so it's just coming from there. Maybe I'll actually arrow to that, so that is crystal clear. So this is negative pi over 4 comma negative 2, just so you can see it in case you don't have access to Desmos. This point right here is 0 comma 0. So let me arrow to that and say that's 0 comma 0. And then this point right here, this is going to be that pi over 4 comma negative 2. So pi over 4 comma negative 2. Let me erase these as I use them. And then this point right here, this is your pi over 2 comma negative 4. So pi over 2 comma negative 4. Let me get rid of that. And then this right here is the 3 pi over 4 comma negative 2. So this is 3 pi over 4 comma negative 2. So thinking about the beginning, the middle, and the end. So at negative pi over 4 for the x value, for pi over 4 for the x value, and then for 3 pi over 4 for the x value, again, you're going to get an undefined value for cosecant. If you plug in negative pi over 4 and you go through the steps there, you're going to end up with the cosecant of 0. And the cosecant of 0 is undefined. If you plug in pi over 4, you're going to end up with a cosecant of pi that's undefined. If you plug in 3 pi over 4, you're going to end up with a cosecant of 2 pi, which is undefined. So on and so forth. So you'd have a vertical asymptote there at negative pi over 4, and then you'd have one at pi over 4, and then you'd have one at 3 pi over 4. Let me highlight this because it's really hard to see. So let me do this one right here, and let me do this one right here, and then let me do this one right here. Really hard to see that one. Okay, so thinking about, you have a shared point here at 0, comma 0, and you have a shared point here at pi over 2, comma negative 4. So again, I know that since this is a hill, this will be a valley. And then since this is a valley, this would be a hill. This is going to be really hard to do, so I'm going to try my best, but I'm going to go over. This would just approach the vertical asymptote, but not touch it. And same thing for this part right here. I'll do my best. And then this right here, this one's going to go down. So approach, but not touch. And approach and not touch. And I know I went over the line in a few places, but just pretend like I didn't. Again, you have that link on Desmos. If this is really hard for you to see, you could just click on that and go into more detail. All right, let's take a look at problem 9. So here we have f of x equals 3 cosecant of x over 2 minus pi over 3 minus 2. Let me go ahead and factor this again. So f of x is equal to, we have 3 cosecant of, let me pull out the 1/2. And then inside you're going to have x minus, how do I undo multiplication by 1/2? I would multiply by 2. So 2 times pi over 3 would be 2 pi over 3. Let's close everything down, and then you have minus 2. Okay, so looking at it, if we want the period, and maybe this e could be better here. Well, we want to go 2 pi divided by 1/2, so that's 4 pi. If we want the phase shift, we're going to come inside here, and we're going to think about, how do I undo what's being done to x? We have x minus 2 pi over 3, so I want to add 2 pi over 3 to undo that. So that means I'm going to the right 2 pi over 3. And then lastly, you have your vertical shift, and you're thinking about this minus 2 right here. That's just going to put me down by 2. All right, let me copy this real quick. Again, I want to try to make it smaller. So f of x is equal to 3. I'm going to replace cosecant with sine. And then you can keep it in factored form, again, if you want to use graphing transformations. So 1/2 times the quantity x minus 2 pi over 3. Close all that down, then minus 2. And paste this in here. Again, I'm just going to start with y equals the sine of x. You have your 0, 0. You have your pi over 2, 1. You have the pi, 0. Maybe this could be a lot better here. Let me just do that again. And then you have 3 pi over 2, negative 1. Let me slide down just a little bit so this fits. And then you have 2 pi, 0. Again, an x-intercept at the beginning, middle, and end. So just remember that. If we're using the quarter period method, again, you could use graphing transformations, but it's going to be slower here. The period is 4 pi. So the quarter period is pi. So the quarter period is going to be pi. Well, first you start off with a phase shift. And again, we're going to the right, 2 pi over 3. So this is 2 pi over 3. And then now you're just going to add quarter periods. That's all you need to do. So 2 pi over 3 plus, you could write this as 3 pi over 3. That's 5 pi over 3. Then you add 3 pi over 3 again. You're going to get 8 pi over 3. And actually, let me just make this a little bit smaller. So 8 pi over 3. And then I'm going to add 3 pi over 3 again. So that's going to be 11 pi over 3. Add 3 pi over 3 again. You're going to get 14 pi over 3. Okay, so for the y values here, again, very straightforward. I know that if I plugged in 2 pi over 3, that this guy right here would turn into 0. If I plugged in 5 pi over 3, this guy right here would turn into 1, so on and so forth. So the shortcut here is just to say that I'm going to multiply by 3 first, then subtract away 2. So I'm getting a vertical stretch by a factor of 3, and then I'm shifting down by 2. So I'm just going to go 3 times 0 minus 2. Here I'm going to go 3 times 1 minus 2. And you could skip this one. This would be 3 times negative 1 minus 2. So this would be 3 times 0 is 0. 0 minus 2 is negative 2. So this is negative 2. 3 times 1 is 3. Minus 2 is going to be 1. And then this one you can copy from here. And then you can put that here. 3 times negative 1 is negative 3. Then minus 2 is negative 5. Okay, so we have this. Let me grab it. Come down here and paste this in. And again, I'll just go through these with you real quick. So if we look at what we have, you have the 2 pi over 3 comma negative 2. Let me just highlight that real quick. And then you have your 5 pi over 3 comma 1. You have your 8 pi over 3 comma negative 2. You have your 11 pi over 3 comma negative 5. And then you have your 14 pi over 3 comma negative 2. So those are your points on the sine graph. Again, at the beginning, the middle, and the end, that's where if you plug those guys in terms of the x values, you're going to get undefined. If you plug in 2 pi over 3, you're going to end up with the cosecant of 0, which is undefined. If you plug in 8 pi over 3, you're going to end up with the cosecant of pi, which is undefined. If you plug in 14 pi over 3, you're going to end up with the cosecant of 2 pi, which is undefined. So you're going to get vertical asymptotes here and here and here. So then all you need to focus on is that at a quarter of the way through and 3/4 of the way through, you're going to have a shared point. So 5 pi over 3 comma 1, and then 11 pi over 3 comma negative 5. So now we know that this right here is a hill, so it becomes a valley, and this right here is a valley, so it becomes a hill. So all I have to do is sketch this going this way, approaching the vertical asymptote but not touching it. Same thing for this right here, and then same thing for this guy going this way, and then this way. So that's all it is. All right, let's take a look at problem 10. So here we have f of x equals 3 cosecant of 2x plus pi over 6, then minus 1. All right, once again, I'm just going to factor. So f of x is equal to 3 cosecant. Pull out the 2. Inside, you're going to have x plus, how do I undo multiplication by 2? I can multiply by half. So pi over 6 times a half, that would be pi over 12. Close everything down, and then you have minus 1. So for the period, you have 2 pi divided by, in this case, 2. So 2 pi over 2, that's going to be pi. Then for the phase shift, you go inside and you say, how do I undo what's being done to x? Here you have x plus pi over 12. To undo that, I need to subtract away pi over 12. So that means I'm going left, pi over 12. Then for the vertical shift, you have that minus 1. So that is going to tell me that I want to go down 1. That's all it is. I keep rewriting it, trying to make it smaller, but I never do. So I'll just go with what I have, and I'll just replace this with sine. And again, one more time, we'll just write y equals the sine of x. Hopefully you know these points at this time. So we have 0, 0, we have pi over 2, and then we're going to have comma 1. We have pi, comma 0, we have 3 pi over 2, comma negative 1, and then we have 2 pi, comma 0. X-intercept, x-intercept, x-intercept. So just remember that. So looking at this guy, again, if you want to do the quarter period method, the period we know is pi. So the quarter period, that is going to be pi over 4. So let me go ahead and say that first you do the phase shift. So we're going to have minus pi over 12. And then from that point, you're going to keep adding quarter periods. You can go ahead and just multiply this by 3 over 3. So this would give me 3 pi over 12. So negative pi over 12 plus 3 pi over 12, that would be 2 pi over 12. I know you can simplify that, but just hold off for a second. 2 pi over 12 plus 3 pi over 12, that's 5 pi over 12. That 5 could be a lot better. And then 5 pi over 12 plus 3 pi over 12, that's 8 pi over 12. Of course, you can simplify that, but we'll do it in a second. 8 pi over 12 plus 3 pi over 12, that is 11 pi over 12. So 2 pi over 12 is pi over 6. So pi over 6. 8 pi over 12. 8 divided by 4 is 2. So that's 2 pi over 12 divided by 4 is 3. So 2 pi over 3. Okay, so we've got everything for x. Again, you can do the quarter period method, or you can go through and do graphing transformations, whatever you want to do. For y, again, it's very straightforward. You can always plug in, but again, we know that if I plugged in negative pi over 12, negative pi over 12 plus pi over 12, that's 0. 2 times 0 is 0. So you end up with the sign of 0. So the sign of this right here, which gives you this right here, you get 0. If you plugged in pi over 6, you'd end up with the sign of pi over 2, which is 1. So you'd have this right here. So all you're really doing is you're multiplying whatever the y coordinate is by 3 first, then subtracting away 1. So you have a vertical stretch by a factor of 3, and then you're shifting down by 1. So I'm going to do 0 times 3, and then minus 1. I'm going to do 1 times 3, and then minus 1. I'm going to do, this is a repeat, so this one down here is what I'm going to do. So it's negative 1 times 3, and then minus 1. So 0 times anything is 0, then minus 1 is negative 1. So you have that there, and then there, and then there. And then 1 times 3 is 3. 3 minus 1 is 2. So that's there. Negative 1 times 3 is negative 3. Minus 1 would be negative 4. So pasting this in, again, this is another graph that's going to be really hard to read. So you can just click that link on Desmos if it's a little bit challenging for you. And so this point right here is negative pi over 12 comma negative 1. Let me arrow to this and say this is negative pi over 12 comma negative 1. Maybe that helps you if you don't have access to Desmos. So this right here is pi over 6 comma 2. So pi over 6 comma 2. Then this point right here, this is 5 pi over 12 comma negative 1. So 5 pi over 12 comma negative 1. Then this point down here, this is 2 pi over 3 comma negative 4. And then this point right here, this is 11 pi over 12 comma negative 1. Okay, we can get rid of this. So thinking about the asymptotes at the beginning, the middle, and the end. So the x value is there. So here, this would be your x value of negative pi over 12. And then at the middle, you can have an x value of 5 pi over 12. So that's that guy right there. And then at the end, you're going to have 11 pi over 12. So this guy right here. So that's the end of the cycle. So again, if you plugged in negative pi over 12 for x there, so you went through this, you'd end up with the cosecant of 0, which is undefined. If you plugged in 5 pi over 12 for x there, you'd end up with the cosecant of pi, which is undefined. If you plugged in 11 pi over 12 for x there, you'd end up with the cosecant of 2 pi, which is undefined. So that's why you're getting vertical asymptotes at the beginning, middle, and end. One more time, if you wanted to, and a lot of teachers do this, you could use the negative 1 there, that shift down, and you could say, well, anywhere where the y value is negative 1, you're going to get your x value that's undefined there. So you could draw the horizontal line y equals negative 1 if you want. That would be your new midline. You could do it that way as well. Okay, so we know that we're going to share a point at a quarter of the way through. So that's going to be right here. That's at pi over 6 comma 2. And then 3/4 of the way, so that's this right here. That's at 2 pi over 3 comma negative 4. And again, with the sine graph, this guy is going to be a hill. So this would be a valley. And then this right here is a valley. So this would be a hill. So let me draw this to where, and this one's really hard to do. It approaches the vertical asymptote, but doesn't touch it. And this one's going to approach the vertical asymptote, but not touch it. Same thing for this going down here. So approach, but not touch.